Questions? All right. Let me move forward. Okay. I'd like to jump in now to a new topic, to another way to represent data. This is called an ogive. An ogive. This is the next representation of data. It's called an ogive. I am now on the model problem. Do we need to restart? You already did. Okay. I'm on where it says model problem about the children.
Oh.
So, the first thing we need to do, and let me make the ogive, then I'll explain why it's helpful. We need to draw ourselves a little table here. Need to draw ourselves a little table. Mm-hmm.
Couldn't you also pronounce it as Ogil?
Yes, you could, but that would be incorrect.
What?
You could pronounce something as a tomato, but that would not be correct.
Dang, you got you there.
I don't even know what that means.
Like tomato, tomato.
Oh, tomato.
So frequency, relative frequency, cumulative, frequency, and the last one, cumulative, relative.
That doesn't make sense. It's still a tomato out of the way, right?
So, here we go. Any questions on the what's written on the board? If you can't read something, please ask. Any reading questions? Frida. Relative frequency, cumulative frequency, cumulative relative frequency.
Yeah, the friend model thing makes sense. One day. One day.
Okay. Now, frequency refers simply to the number of times something happens. So let me fill in some data here. So you might be asking yourself, where did we get this data from? Well, if you look at all the numbers, there are 6 numbers that are between 10 and 19. There are 9 numbers between 20 and 29. There are 11 numbers between 30 and 39, 14 numbers between 40 and 49, and 4 numbers between 50 and 59. Next.
That's 6, right?
That is a 6, yes. Questions? So, frequency, the number of times something happens. Relative frequency relative frequency is equal to the frequency divided by the total. Frequency divided by the total. This is a proportion, but we express it as a percent. The total, in this case, if I add all these up, 20, 40, 44. So the relative frequency is 6 divided by 44, 9 divided by 44, 11 divided by 44, and so on.
And you want in percent?
And we write it in percent. So 14, and these are about, right, we do a little bit of rounding here. 21%. 25%, 32%, and 9%. And yes, this adds up to 101%. That's because of the rounding. That's fine. Okay. Let me continue on. And this graph will, and once I make the graph, it'll become apparent why we're doing this. The next column is cumulative frequency, which is basically the sum, or no, it's just the total numbers below a value. Total numbers below a value. So, by way of example, the cumulative frequency here will be 6. Here, it'll be these 9 plus these 6, 15. Because there are 15 numbers in the data that are below 29. Over here, we'll have 26. We have these 11 that are below 39, these 9 that are below 39, and these 6 that are below 39. 49. It'll be this plus this plus this plus this. 40 numbers. And finally, all the numbers are below 59. Shamira.
So you're including the number itself because like 6 is below the 6.
No, I'm saying below 19.
Wouldn't that be 8?
There are only 6 numbers below 19 in the data set. In the data set. And if you look in the data set below 19, I have 6 numbers there. Now over here below 29, there are 9 numbers from 20 to 29, and then these 6 numbers are also below 29. That's how we get the 15. There below 39, there are these 11, these 9, and these 6, and so on. Questions? Okay. Then we have cumulative relative frequency. Which is just equal to the cumulative frequency divided by the total. So all we do is the following. I need to clean this board properly. And now we can draw the graph that is very helpful. Can be. So on this axis, yeah, right? On this axis, we will plot cumulative relative frequency. And over here, we will plot the scores, the DRP, which is the name of the test that they got the data from, DRP scores. Now, over here on this axis, we measure it like 0.1, 10%, 20%, 30, 40, 50, 0.6, 0.7, 0.8, 0.9, and then 1, or 100% of the data.
Wait, are we using a histogram?
No, it's not histogram. It's not histogram. This will be a line. Down here we have our scores, 10, 20, 30, 40, 50, 60. So here we go. I'm going to plot the cumulative relative. I'm going to plot this. Oh yeah, so this is a percent here just to save space. We don't write 10%, we just do 0.1. It's the same, right? It's the same thing. But yeah, you're right. We just do a save space over here. This we always write in percentage. This reason they always do it in a decimal. So all we do is the following. From 0 to 10, there is no data. So you just draw a straight line here. Now, at 19, there is 14% of the data. So 19 is about here. 14% is probably about here. So I'm just going to connect this line. At 30, or excuse me, at 29, there is 34% of the data. So I'm going to come over here to 29, come up here to 34%, right here, connect the dot. It will not, of course, always be so linear. We're about to see why not. 30 to 39, 59% of the data. So 39, 59% of the data. Right. 49, 91% of the data. 49, 91% of the data. And then by 59, 100% of the data. And here we have it. Why is this helpful? Because we can easily see where the quartiles are. We can easily see, boom, here's the number where 25% of the data is. Here's the number where 50% of the data is. Here's the number where 75% of the data is, and so on. Now's a good time to take questions on how to draw this thing. By the way, you could have drawn this on the back in your sheet. Sorry about not saying that. Okay, so let me ask some questions. What score is at the 20th percentile? So I would come up here to 20th percentile. Excuse me. Percentile is measured here. Come over here to 20. Come on over. And I don't know, something like 23, 22, 23. What score is at the 90th percentile? Come up here to 90. Go ahead and scroll over. Come down. And maybe about 40, 49, 48, 49. What is the median score? What is the median score? Giselle, what's the median score here? How would I find that? What percentile would I go to here? Okay, good. And what score am I going to get?